Good afternoon. To start with, I would like to say a huge thank you to the organizers of PHPConnect 2025. Can we put our hands together for them? And so when I was preparing for this talk, one of my headache was that I could come here and I'm seeing people that don't even know what a container is. So you can imagine how excited I was to see one of the speakers earlier talk about Docker-driven development. So I think to an extent, it makes my work easier. Can we appreciate the speakers that I've spoken earlier? Okay, let's dive right in. So, who am I? Okay, I'm not seeing that on the screen. So I'm Tobi Anifowose. I work as a software engineer with Tightline Software. And when I'm not doing that, I'm working on PHP Sandbox with Bosun. You should check it out. PHP Sandbox is an online IDE. Okay. All right. PHP Sandbox is an online IDE for PHP developers. All right. It's an online IDE for PHP developers that allows you to build the same way you would with your regular IDE, but you can do that directly from your browser. And the third thing about me is that, The third thing about me that you should know is I never walk alone because I'm a Liverpool fan. And my team is tired of sitting at the top of the EPL table. So, all right. So, what exactly are we trying to achieve with this talk? Now, over the past 3 years, I've been working with a fantastic team. And what we've been doing is helping businesses move their applications from running on virtual machines and regular servers to running on Kubernetes and using general cloud native toolings. And I've worked mostly around PHP applications for this. And one of the things I noticed is that during the course of the work, it showed me that there is a way you build PHP applications for this kind of environment. Okay? There's a way you build your PHP application when you know that you will just be hosting it on a regular server. But then when you know that you'll be running it in a containerized environment using tools like Nomad, Docker Swarm, Kubernetes, it changes the way you think about how you build your application. So that is the essence of this conversation. All right, so let's get started. So meet my friend. My friend is Bob. And like Kieran said earlier, we need to ship. You've built awesome applications, right? You need to show the world what you've built, right? So which means you need to host it somewhere, right? You host it somewhere for people to have access to it. So this, my wonderful friend here, Bob, is a PHP developer and is building a social networking application. Now, he built it very fast, like we've learned, and the application, so Bob is building a social networking application, and his application is quickly gaining traction. But then Bob started building his application in the early days of PHP. And you know what that means? It means you are most likely using a shared hosting service. You are most likely using a LAMP stack. And you are most likely uploading your code using FTP. How many of you ever did that? So let's look at some of the tools he started with. He was developing locally using this guy. How many of you are familiar with XAMPP? Right, okay. And I think Sublime Text is still a bit more relevant. And he was writing this code with Sublime Text. And he was using this guy here, FileZilla, to upload his code to his server. That guy once took 3 hours to upload a Laravel project for me. And he was managing his servers using a cPanel. So this was how we started. But then, he shipped, and his application grew very fast. And all of a sudden, he moved from being a single developer to becoming a CTO. Then he now has other worries. He has more servers. He has larger teams. complex configurations and OS headaches. It now has several developers who are somehow using WSL on Windows to code, and some using Linux and some using Mac OSs. And they have to worry about all of these things, okay? In his early days, he goes up to his server, configures it manually. If the server is supposed to have a particular binary at a particular path, he will go there, manually add it himself, and it works. But all of a sudden, all of that becomes operational issues, right, that delays the team as they try to make releases. So he probably met one of our speakers here, and he decided, look at that, I'm going to switch to cloud, and I'm going to adopt Docker containers. And that opens a lot of opportunities, because, for example, it means that he doesn't have to host his application on his own local servers. He can go on AWS and buy as many servers as he needs, as long as he can pay for them, right? And with Docker containers, he can containerize his application so that they give exactly the same experience, irregardless of where they are running, right? So no more OS headaches. If it works for me, it must work for you. If it's not working for you, it means it wasn't working for me. I probably just lied, right? So, you know, that bridges the gap of all of that for him. Now, when you combine that with orchestrators like Kubernetes, Nomad, Docker Swarm, it just makes your life easy. I was in my team one day. We had high traffic, unexpected high traffic, and we needed to, you know, quickly scale our applications to handle that traffic. And with Kubernetes, we were able to do that under 5 minutes. We were able to quickly scale up to like 3 times our current pod numbers under 5 minutes, and it just works, right? So it helps him scale, you know, dynamically based on demand, and no more OS worries. Production and development environments are finally unified, so you don't have to think about, oh, it works in my local, will it work when I get to production? And, you know, everything was nice until the problem started. And you can see that guy's picture there. You know, when I saw the picture, I said the first thing that will probably get him that way are his AWS bills before the code itself. Now, all of a sudden, he realized that the same code that he was running on his normal regular servers, he brought them to run in a containerized environment and orchestrated them using Kubernetes. All of a sudden, they no longer work, right? And that is because running your applications in a cloud-native environment requires a different way of thinking. And that is because of the nature of the environment itself. So containers are at the heart of, you know, cloud environment. And one of the fundamental attributes of containers is that they are meant to be ephemeral. And what that means is that a container is not designed to live forever. If you set up a virtual machine, your virtual machine can stay there, maybe just sometimes it gets rebooted, but it can be there, you know, for as long as you need it. But a container can decide to go down for so many reasons, right? You can have a process running inside it, and it just gets OOM killed. And you need to create a new container so that you can continue serving your applications. So because of these fundamental differences in how containerized environment works as to how your regular servers work, it requires you to then pay attention to some things that you probably would not have to if you're running your application in a regular environment. And 2 things I want us to take away from here, which you will hear me say consistently as I proceed. Number 1, containers are ephemeral, meaning your container can die and you have to restart it, right? And in a container, nothing persists by default. The earlier speaker mentioned how that when you run your code in containers, it has its own isolated file system. What that means is that container A does not know what container B is doing, right? And on a regular server, you know, you have just one server running your application. But then in a cloud environment, you could have 10 containers running the same application, yet they are not even aware of each other, right? Container A is not aware of what container B is doing or has done. So this affects how you think about your PHP application. And that is the purpose of this call. So I will try to just cover as much as I can with the time that we have. So let's look at a few things which could meet some people as a root shock if you don't understand these differences in environment. Now, the first one is session management. Now, have you ever logged into an application before? Can you raise your hand? Great. So when you log into an application, the application somehow knows that you are Tobi, right? And every other thing you want to do, the application ties it back to your identity on the platform. Now, if you're running your code on a regular server, when a user logs into your platform, what you would do in your code is to create a session. You see that in my code here. You start a session, store some relevant information in that session, and just leave it that way, right? You can always come back to access those informations later. And what PHP would do by default is that PHP would create a session file and store it on the server disk, okay? PHP stores your session files there, and it works. Now, when you bring the same code in a containerized environment, there are two potential issues you will quickly run into. The first one is that a user has logged into the platform, is using it, and one of your developers decided to make a production release, and he made the production release, and you have to roll over the containers so that you are running the new containers, running the most updated code. All of a sudden, the session file that PHP had created earlier for that guy no longer exists, because the new container has its own isolated file system and doesn't know that there was a session that was created for someone earlier. So what happens every time you deploy? All your users will get logged out, right? So imagine you're using Twitter, and because they had 3 deployments within an hour, you have to log in again 3 times. You definitely don't want that. Now, a second potential issue you would have here is that you're running your application on, say, 5 containers, and the user tries to log into your platform. So he logs in, the request to log in goes to a particular container, say container A. And PHP creates a session file for it, and now he goes to his dashboard, he wants to update his profile picture, but the request to update his profile picture is going to a different container, say another container C somewhere, right? Now, container A is aware that this guy has logged in and knows his identity, but container C has no clue. So what will container C say? Hey, you need to log in. I don't know who you are. So what happens is the guy just gets redirected back to his login screen, and he's wondering, what the hell is going on here? I just gave you my username and password, right? So when you're running your application in a cloud environment, you need to change how you handle your sessions. And PHP already offers ways that you can handle this. What you need to do is to look for an external service that is going to handle your session data. So PHP already allows you to use a service like Redis, right? And I believe Laravel even allows you to use your database. If you're using Laravel, you have several session drivers that you can set up. But the key thing is you can't use the file-based one, right? It must always be something external to the container itself. So let's move quickly. Let's talk about file system. So this is a code. I hope you can all see it clearly. This code is doing something very simple. There's a process that is meant to run once a day. This code is going to send out mails, right? We don't want to spam users with mails. So the code is meant to run exactly once per day. Now, when the code runs, it will generate a log file, and that file will be saved somewhere, so that if a process retriggers this job again, it will just check, oh, this log file exists. That means it has run earlier today, so don't bother running again. And you've deployed this on your server, and it works perfectly fine until you moved to containers. Now, what happens is that this process ran, say, earlier this morning, but then you have a developer who just deployed code again, so your containers died and new ones were created. The new container has no idea that the log file you had created earlier exists. It has no idea. Again, because containers are ephemeral and they have isolated file systems. So what happens is that this process is retriggered again, and it will send another mail. So your containers get rotated again later in the evening. The process is triggered again. You send another mails. You end up sending 100 mails a day to your users, And that is definitely not an experience that you want for them. So how do you go about this? The first thing is that anything that you want to persist must be stored outside of the container itself, right? Because containers, again, are ephemeral. They are not meant to last so long. So anything that you want to store, that you want to persist, should be stored outside of the container. So you can use services like, S3 Bucket, Cloudinary, or any other storage solution and actually upload your files there, right? Now, there's a more technical example option, which is you can use external volumes, okay? Containers allows you to mount external volumes into them such that files you store in that external volume are available in your container, and because the underlying technology itself is outside of the container, your files remain even when your container restarts. Okay, let's talk about another thing, logging. Now, how many of you have had to debug an issue in production before? How do you imagine debugging an issue without seeing any logs? It's like walking in a dark room and you don't have any source of light, right? Logs sometimes make us feel like superpowers. When I work with non-technical people and they're like, oh, this issue happened. Tobi, do you have any idea what's going on? I look at the logs and I'm like, oh yeah, this was what the user tried to do. And the guy was like, wow, that's great, right? Because you need to have access to your logs. But again, when you're running in a native server, right, in a virtual machine, your server, Apache, Nginx, they would normally write access logs, error logs, just logs that are relevant in case you want to debug an issue. They are stored, usually in the var log folder, right, if you're using a Linux distribution. And say your frameworks like Laravel. Laravel would also, by default, write logs to a laravel.log file, right? Now, again, the file system is ephemeral. It is isolated, and once your container restarts, you lose access to everything. So which means that having your logs stored in files simply won't work, okay? So you can't do that in a containerized environment. So what do? The best practice is that have your logs streamed out to your container's std out or std error, right? Let all your logs just go there. You can configure Apache, you can configure Nginx to send their access logs and their error logs to the standard out of your container. And you can then set up a log aggregator. Log aggregators are toolings that they can look out for logs that are coming out from your container, provided they are going to specific locations, and they can collect these logs and put them somewhere you can always come to check them later. So for example, you can set up something like FluentD or Promptail and set it to send logs to, say, tools like Elasticsearch or OpenSearch. All right, so quickly, another one here, caching. And I was going to omit this, but then I believe the default Laravel cache driver is file-based cache, right? So if you just take that and throw it into a containerized environment, again, it simply won't work because the file system is isolated to the container, so which means whatever it is that you think you have cached in one container, the other containers are not seeing it, right? So again, you need an external service that all the containers can have access to read the data from it. So for caching, we have other cache drivers you can explore like Redis and Memcached. All right, cron jobs and queue workers. On your regular server, you would have supervisor most likely set up running your queue workers. You have cron D running your cron jobs. But in a containerized environment, you want to run just one process in your container, right? And that is so that if that process fails, a tool like Kubernetes would know that this process has failed, I need to restart the container. But then if you have more than one primary process running in your container, the underlying one can fail, but as long as the primary one is still running, nobody knows anything is wrong, right? And your queue worker could stop working, and you have no idea. Okay, I'll skip this, I don't have time, and I'll just go right here. Now, there are coding paradigms or software development paradigms that you can embrace that would allow you build better for cloud-native environments. And a very key one that has really helped me so far is what is called the 12-factor app. If you go on Google and you type 12-factor app, you will see it's a set of 12 principles that can guide you in building applications that can run comfortably in a cloud-native environment. Some of the things I've said earlier today are mostly, things I've also learned from these principles. And I'm sure you're going to find them very, very interesting. All right, so key takeaways here. Everything I've said so far is that containers won't live forever. Containers are created to die within a short time. And they have isolated file systems. So anything that you are trying to handle in your code, in your application, that requires persistence must be done outside of the container. So this philosophy would guide you as you're writing your code. So as you write your code, you ask yourself, can this code survive a container restart? Can this code survive the ephemerality of containers? And that would help you answer the question of if your code can actually run in a cloud-native environment. And that brings me to the end of my talk. Thank you very much.